So the first question we have in here now is that a boat or an aeroplane has a pointed or tapering head, tapering front or head. Why? They're asking us that, you know, that we have all seen an aeroplane before, either physically or in a movie. You will see that all the aeroplane, they always have tapering end. That is, their end is always like something like this. Like it's always in this form. Have you ever asked yourself that why? Okay, the reason why they always have this tapering end. Why? This is a louder question. They said a boat or an aeroplane has a pointed. Why is it that the head is always pointed or tapering front or end? Why? To increase its weight, to reduce fluid friction, to look good, to increase fluid friction. You know, there are some things you have to actually inculcate the habit of understanding the question. Let's say you've not seen this question before and you've not seen this question before and you were asked this question. How do you think you can answer it? Now, firstly, do you think the plane is going to have a pointed head because they want to increase the weight? No, never. It will never have a pointed head because they want to increase the weight. But do you think it's because it has to look good? No, it can't be this also, because even if the head is not pointed, the plane can still look good. So for it to look good, no. But now, guys, is it to reduce fluid friction or to increase fluid friction? What you have to notice is that we have what we refer to as friction. Now, you see, we have what we call fluid friction. So when plane is moving in the space, it experiences a retarding force that will be opposing its motion. And that force is known as friction, because friction is a force that opposes the motion of an object. But when the body is not moving in the space, that is, it is moving under the influence of gravity, or it is moving in the space where you know that when you are flying, you are going to have you are going to be experiencing some air force, that is going to be pulling you back. Are you there? So that air force that is pulling you back can be referred to as friction. But what type of friction? We call it what? Fluid friction. So the major reason why plane always has a pointed head is to reduce fluid friction. So the answer is B. The answer is B, to reduce fluid friction. The next question we have here is this. The question is, a boy changes position from x equals 5 meter to x equals 200 meter, then back to x equals 5 meter. The displacement of the axis is this. Now, in this type of question, they are very simple, but you have to understand what the question is asking you to do. Look at this question. Let's say this is the 5 meter. This is a 5 meter. That's a 5 meter. It changes from 5 meter to 200 meters. So this simply means it moves to 200 meter. 200 meter. So you have to understand that as it is moving to 200 meter, it is actually moving forward. And once it moves forward, it is positive. As it is moving forward, it is positive. But now, they then say that then back to 5 meters. So this simply means that once it reaches this 200 meter, it goes back to 5 meter. So when it is going against its motion, that will be negative. So this simply means that if you are dealing with displacement, it is a vector quantity. We will always take into consideration the direction. If you are dealing with displacement, is a what? Vector quantity. And we always deal with what? Direction. So this simply means that from this 5 to 200, it covers 195. It covers 195 meter. Someone will ask me that how does it cover 195 meter? The difference between 5 and 200 is what? 195. So as it moves from 5 to 200 meter, it covers a displacement of what? Plus 195 meter. but it now moves from this 200 back to 5. It also covers 195, but since it is moving in opposite direction, so its displacement is going to be what? Negative. So this simply means that the total displacement it covered will be plus 195 minus 195, and this gives us what? 0. So the answer is what? The answer is option C. So as it moves from 5 to 200, that is plus. As it's now moved from 200 back to 5, that is what? Minus. So plus, and minus, they're going to give us what? 0. So that is why whenever you see this type of question, when it moves from, it starts from a particular point, it moves to a particular point. From that point, it now moves back to its original point. The displacement is going to be what? 0. Okay, the next one we have here is this. The question is still on friction, guys. So guys, don't forget to share the live, please. Share the live. Okay, the question we have here is still on friction. The question is, friction is the value, dash friction is the value of the limiting friction just before slipping occurs. You see, if you don't understand the English here, you might have a little problem, even if you've not read this particular aspect before. If you see this question in exam, you should be able to approach it. How? Because, you know, they say dash friction is the value of the limiting friction just before slipping occurs. What do we mean by slipping? Slipping is when, in Yoruba, we call it think about yo. Are you there? Slipping is when something yo. Toba yo. That's simply when you are talking about slipping, we are still talking about what? Moving. Do you get that? So this simply means that we are talking about what type of friction do we have before an object moves. Now let's look at the option, sliding. You see that sliding also means movement. Rolling. Rolling also means movement. Dynamic. You see, if you're talking about dynamic or kinetic, we are still talking about what? Movement. Static. But static simply means it is what? It is at rest, not moving. So the right answer for this question is going to be what? Static friction. So static friction is the friction that occurs before slipping occurs, because slipping simply means what? Movement, and static simply means at rest. So before movement, that simply means it is at rest. What type of friction is that? That is what? Static friction. So notice that also. The next one is that dash friction is the value of friction after slipping has occurred. After slipping has what? Has occurred. Then in this aspect now, you see that option A is sliding. It also means movement. Option B is rolling. It also means movement. Dynamic also means movement. Static means at rest. So since slipping has occurred, that simply means that static is going to be wrong in this particular aspect. But the answer can now be either option A, option B, or option C. Which one do you think the answer is going to be? What you have to understand now, guys, is that we have basically two types of friction. I lost my red pen and it's paining me actually. I've not seen another place to buy this red pen again. Okay, so we have two types of friction, basically. Actually, we have like four types of friction, but generally we have like two types of friction. The first one we usually talk about is dynamic. Dynamic. And the other one we usually talk about is static. You see, this dynamic can also be called kinetic. So guys, if I'm talking about two types of friction, we have static friction, we also have what? Dynamic friction. But before I even talk about them in friction manner, whenever you hear the word dynamic or kinetic, what does it mean? Guys, let me take you somewhere. Guys, once you hear the word kinetic energy, what does kinetic energy means? We all know that kinetic energy means energy possessed by a body by virtue of its what? Movement. Oh, energy possessed by a body by virtue of what? Movement. So if you're talking about kinetic, this simply means there is what? Motion. Okay, let me ask you another question. Have you heard the word dynamic before? Yes. Remember that when we were doing mechanics, we talked about kinematics and we also talked about dynamic. Both kinematics and dynamic, they are both dealing with what we refer to as what? Motion. But motion without considering the force is called kinematics. Why motion when considering the force is called what? Dynamic. So this simply means that at a dynamic, at a kinetic, they are talking about what? Motion. That is movement. But we just use them in different contexts. But they still mean the same thing, which is what? Movement. So therefore, guys, you will now understand another thing now. That this dynamic friction is the friction when the body is already what? Moving. But guys, we can have different type of movements. You know that you can be walking, that's a movement. You can be swimming, that's a movement. You can be sliding, that's a movement. Yes, you can be sliding, that's also a what? That is a movement. You can be rolling, that is also a movement. So this simply means that the type of movement we can have, they can be in different form. They can be in different form. Movement can either be rolling in case of like a drum. Movement can either be sleeping, let's say to buy jaw. Movement can just be a normal movement, like that is if you are walking. Movement can be in swimming format. Movement can also be in flying format. So that is why this dynamic friction can be subdivided into sliding friction, rolling friction. So this simply means that this type of question now might seems a little bit confusing, but you have to make sure you understand what the question is asking you to do. The friction is the value of friction after slipping occurs. The right answer is what? Dynamic. So the reason why the right answer here is going to be dynamic is because this dynamic simply means the friction when motion has started. So this dynamic can now be sliding or rolling. So the right answer is what? Dynamic. Okay, so please let's keep sharing the live, guys. Let's keep sharing the live. So those are the questions. Don't forget, we are moving on to 25 questions today. And by God's grace, let me see my availability tomorrow. We need to solve 75 questions. You know, I provided you with up to 1,000 questions of lateral question. Don't worry, we are going to solve everything together. We are going to solve it from now till Sunday. Actually, the physical tutorial is going to start by January 3rd for those in school already. But we are going to be starting fully by January 6th. So what we are going to be doing now is that we are going to be solving questions. We are going to be doing it live for those not present physically. We will also be doing it night classes at college, you know. So that's what we are going to be doing now. By God's grace, you are going to surely have your good result. Don't worry. Whether you see left and right or you don't see left and right, you will surely pass. Just make sure that you are following everything we are doing. Okay? Now let's move on to the next one. So let's move on to question number 5 now. Question number 5. Now everybody should please listen attentively to this question number 5. Because this particular question number 5, I have another interesting question that they usually ask for this question number 5. You see, if M1 is equals to 5 kilogram, M2 is equals to 6 kilogram, X1 is equals to 2 meter, X2 is equals to 3 meter, respectively, find the center of gravity. You see, this question, as simple it is, it might also be very confusing. In what sense? In the sense that once you've not heard of the word center of gravity before, you will have a little problem here. What is the center of gravity? What is the center of mass? Don't stress yourself. For the sake of this question, we are calculating the center of gravity. So guys, let us firstly note the formula for center of gravity. Whenever they ask you to calculate the center of gravity, the general formula is this. It's going to be, you will open a bracket. Now it's going to be this. The mass 1, M1, times the distance of X1 plus the mass 2, M2, times the distance of X2 all over total mass M1 plus M2. This is the formula you have to use, guys. If someone does not know this formula, trust me, no matter what you are doing, you are not going to get your thing. So therefore, guys, knowing this formula, you don't have any problem. Just substitute. Your M1 is 5. That is 5 times your X1 is 2 plus your M2 is 6. Your X2 is 3. All over 5 plus 6. That's it, guys. So therefore, guys, you don't have to stress yourself. So, you know, most of these things you are doing on the level exam, not jump. Jump, you need a calculator. Do you get that? But in another level, they're going to accept calculator. So what you've written now, just press it on your calculator straight to get your final answer. So look at how I'm going to be pressing the calculator. Now, you see that this question I have here starts with what? Brackets. I'm going to open this bracket. I will open brackets. Hope everybody can see. It means an object will be static before sliding. Yes, actually. Rufus, yes. An object is going to be static before sliding on. That's it. So you will open the bracket. Once you open brackets, you will open the bracket. Once you open bracket, you are going to press the fraction. This is the fraction button. You will press this fraction button. Are you there? So at the top, you can see that the cursor is blinking up here, right? So therefore, you will firstly open a bracket. Open this bracket. Press 5 times 2. Close the bracket. Can you see how I'm pressing it? Then you are going to press plus. Open the bracket again. 6 times 3. 6 times 3. Close the bracket. Control the cursor down. 5 plus 6. You will now press this forward button to control the cursor up here. You can see the cursor is now blinking here. Then close the bracket. Then press equals to. Then press SD. What do you get? 2.545. Then if you go to the option A is 11.25. Option B is 2.55. That simply means that the right answer is what? Option B. You can see the question is very simple once you know the calculator. Once you know the formula to apply. So that's how to do it, guys. You can see it's very simple. This is the first 5 questions. Don't forget we are going to 20 questions. I have some particular interesting questions we are going to be solving today. You see this question, they are very simple. But if someone missed out a particular point, the person is going to miss a lot. So that is that, guys. So make sure you've studied this very well. Then let's move on to the next set of questions now. This is question number 6. Question number 6. Everybody follow me? Now, the question I have in number 6 now is very simple also. But I have to listen attentively. They said the international system of quantities has dash quantities. Guys, listen. The international system of quantities has dash quantity. The options I actually put here, we can say there might be some mistakes here. But let me explain something to you. You see, you don't have to stress yourself too much. You see, what you have to know is that when you know something, be proud of yourself. Although, make sure you're not just proud on Odo. Make sure you're not just proud on an empty head. But when you know something and you are sure of yourself, you have to be proud. And you have to be confident of yourself. Are you there? So if you're talking about the international system of quantities, what you have to understand is that we have 2. Basically, we have 2. We have the fundamental. We have the fundamental. And we also have the derived. So we have the 7 fundamental quantities and we have the what? 2 derived. Sorry, we have fundamental quantities and we have what? Derived quantities. But you say these fundamental quantities, these are the quantities that are fundamental. They are basic. Are you there? And what do? They give rise to other quantities. Surely in Yoruba, Alekpan fundamental as the quantities they are like equile. They are like the foundation of other quantities. These fundamental quantities, they are the quantities that give rise to other quantities. So the international system of units, we can say we have 2 of them. We have the fundamental, we have the what? Derived. But how many fundamental quantities we have? We have 7 fundamental quantities. Why how many derived quantities we have? We have numerous derived quantities. We have numerous, that is plenty derived quantities. So this simply means that in this option I put here, this option here should actually be 2. This option here should be 2. It was a mistake when I was writing it. So the international system of quantities has dash quantities. We have what? 2. That is fundamental or derived. But if they ask you that, how many fundamental quantities do we have? Then the right answer is going to be what? 7. Do you get that? But if they ask you that, how many derived quantities do we have? We have what? Numerous derived quantities. So all the quantities, apart from the 7 fundamental quantities, they are going to be what? Derived quantities. So therefore, guys, let's move on to the next one. So study this. This should be 2. That's option A. Now let's move on to question number 7. Yes, we also have supplementary quantities. But the thing is that what you have to notice is that you know that when I was teaching the physical quantities, I said we have 2. We have the fundamental or we have the what? Derived quantity. But I said that apart from the 7 fundamental quantities, we also have 2 supplementary quantities. So we can also have what we refer to as supplementary quantities. They are just 2. Either they are just two. So most of the time we don't talk about them. But the two supplementary quantities we have are the what? Solid angle and what? Plane angle. So we don't really talk about them. That is why we don't really that. Okay. So now let's move on to this particular question, guys. Angle between two vectors, A is equal to this and B is equal to this is dash. Guys, you see this particular question, it is very simple. But how simple it is, you have to make sure that you understand what the question is asking you to look. Guys, the question is asking me to look for what? Angle. So since I'm looking for angle, that simply means I'm looking for theta. Guys, I'm looking for theta. I'm looking for theta. Okay, guys, I'm looking for theta. I'm given the angle A to be 5i plus 3j minus 6k. And angle B, this is angle B. This is angle B, and this is angle A. 3i plus 2j plus k. So I have angle A, I have angle B. Now, guys, please listen to me here. I'm looking for theta. You see, whenever you are looking for the angle between two vectors, you are to be using this formula. A dot B equals magnitude of A, magnitude of B cos theta. This is the general formula to be used. This is the general formula to be used whenever you are looking for the angle between two vectors. Guys, listen. This formula can lead to the modification of this. That is, I can toss this formula to something like cos theta is equals to A dot B over magnitude of A, magnitude of B. Guys, you can see what I'm doing. So whenever you have to look for the angle between two vectors, you have to be using this formula. I can modify this formula into this. It turns to cos theta is equals to A dot B over magnitude of A, magnitude of B. Guys, the next thing you now have to note is that I can now make this theta the sorry formula. Then, guys, I'm going to get the formula to be theta is equals to cos inverse, open a bracket, A dot B over magnitude of A, magnitude of B. Guys, that's it. So this simply means that if I want to look for the angle between two formulas, between two vectors, so I am to be using this formula. So it's very simple. The problem that someone is going to have is that if you don't know about this before, that is when you are going to have a little issue. But once you know about this, you don't have any problem. Are you there? So remember this formula. So therefore, what are you going to do now? We are going to do, we will firstly do A dot B. After doing A dot B, we are going to do magnitude of A, magnitude of B. So let's do that, guys. A dot B. Now, guys, if I want to do A dot B, it's very simple. Just listen to what I'm doing. Listen up. It is as if I am using this vector A to multiply vector B. Guys, don't panic. It is as if what? I'm using vector A to multiply vector B. Guys, let's do this together. In vector A, we have 3i. In vector B, we have 5i. So before I move on, you have to understand something that whenever you do I dot I, the answer is 1. J dot J, the answer is 1. K dot K, the answer is 1. So this simply means that if I don't want to stress myself, what am I going to be doing? I'm going to be multiplying similar unit vectors in vector A and vector B. In vector A, there is 3i. In vector B, there is 5i. Guys, what is 3 times 5? That is 15. In vector A, there is 2j. In vector B, there is 3j. Guys, what is 2 times 3? That is 6. That is plus 6. In vector A, there is k. That is 1k. In vector B, there is minus 6k. What is 1 times minus 6? The answer is minus 6. That's very simple, guys. What you will just be doing whenever you are doing the multiplication whenever you are doing the dot product of two vectors, you just multiplying the similar unit vectors together. Because I dot I is 1, J dot J is 1, and K dot K is 1. So what is 3i times 5i? That is 15. Because I dot I is already 1. What is 2j multiplied by 3j? That is 6. Because J dot J is also 1. What is K multiplied by minus 6k? That is as if I'm doing 1 times minus 6. The answer is what? Minus 6. So my A dot B is equals to what? 15. That's it. That's it. Okay, guys, I'm to do the magnitude of A. Magnitude of A will just be whenever you are looking for the magnitude, guys. Whenever you are looking for the magnitude, you will just write square root. That's it. So, what is the coefficient of I in vector A? That is 3. You will just open brackets, put 3. Plus, open another bracket. Guys, in vector A, what is the coefficient of J? That is 2. Close bracket. You will put square here. You will also put square here. Plus again, open bracket. What is the magnitude of K? What is the coefficient of K in vector A? That is 1. 1 again, open bracket, squared. That's it. This then equals to magnitude of A, this equals to square root. Guys, what is 3 squared? 9. Plus, what is 2 squared? 4. Plus, what is 1 squared? 1. What is 4 plus 1? 5. What is 9 plus 5? That is equals to 14. So my magnitude of A is root 14. Also, guys, I'm going to do the magnitude of B. That also equals to square root. Guys, doing the magnitude of B, what is the coefficient of I? That is 5. Open bracket, write 5, square. Plus, open another bracket. What is the coefficient of J here? That is 3. Write 3, square. Plus again, open another bracket. What is the coefficient of K? Minus 6. Write minus 6, square it again. This equals square root. What is 5 squared? 25. Plus, what is 3 squared? 9. Plus, what is 6 squared? That is 36. That's it, guys. So we are going to add everything together. Then the magnitude of B can equals to square root. What is 25 plus 9? 25 plus 9 is going to be 34. Then what is 34 plus 36? That is going to be 70. So therefore, finally, my theta is going to be cos inverse my A dot B, that is 15, over magnitude of A, that is root 14, times magnitude of B, that is also root 70. Then close the bracket, equals. Now, at this point, guys, okay, someone said it is minus 36. Now, listen attentively. If you are doing the magnitude, you have to make sure that you open the brackets. Are you there? So, minus 6 square. Minus 6 square is going to be 36. It's going to be plus 36. At Banuso, I don't really see your number, I'm sorry. So, you have to understand something that minus times minus is going to be plus. Are you there with me? So, that is why minus 6 square is going to be what? 36, not minus 36. Do you get that? Thank you very much. So, therefore, guys, our theta that we have to calculate, which is the angle, is going to be this. So, just bring out your calculator, guys. Look at how we are going to do it. You see that the first thing we should do here is to press cos inverse, right? Now, guys, how are we going to press the cos inverse? We are going to press shift and cos. So, press shift, then press cos. That is cos inverse, right? We have the fraction. Press the fraction button. This is the fraction button. Press it. Then, we are going to press 15. At the top, we are going to press 15. You will now control the cursor down and press, control the cursor down, then press root 14. You will control the cursor out of the bracket of the square root times root 70. You will also control the cursor to the other side, then close the bracket. So that will be cos inverse 15 over root 14 times root 70. Then press is equals to, then the answer we got is what? 61.369. So this simply means that approximately the answer is going to be what? 61.37 degrees. So therefore, guys, this simply means that the right answer for this question number 7 is what? Option C. Option C. So therefore, guys, make sure that you study how we are doing this. It's very simple. Just make sure that you don't miss any step once you are doing this. Now, guys, let's quickly move on to the next question. The next question we have in here is that a car moves at a velocity of this. This is the velocity of the car. What is the unit vector of the direction of the motion? Guys, once we are talking about vector, if we are talking about vector, we have what we refer to as unit vector. Unit vector is a vector that has a magnitude of exactly 1. So therefore, guys, if they ask you to calculate the unit vector, you have to remember this formula. There is a general formula for unit vector. Look at me. Unit vector, the formula for unit vector is equals to vector given all over magnitude of vector. So this is the formula you have to note firstly. The formula for unit vector is what? Vector given over what? Magnitude of the vector. In this particular question, the vector given is this. The vector given is equals to 4i plus 3j plus 0.1k. The unit of this vector is meter per second. So guys, you have to understand something here. Vector quantities are quantities that have both magnitude and what? Direction. Right there. So what you have to understand now is that once you've gotten the vector given, you are going to calculate the magnitude of the vector. So let's calculate the magnitude. Magnitude of the vector. Now the magnitude of this vector is going to be square root. It's going to be square root. What is the coefficient of I? That is 4. That will be 4 squared plus coefficient of j, that is 3 squared, plus coefficient of k, 0.1 squared. If you bring out your calculator, you are going to press square root 4 square plus 3 square plus 0.1 square. Then this is going to give us 5.00. So the magnitude of this vector is what? 5.00. But now, guys, you have to understand something. We can also refer the magnitude of a vector as the resultant of the vector sometimes, or the modulus of the vector. Right there. So this magnitude of this vector right there is going to have the same unit as the vector. So the unit of this magnitude is going to be what? Meter per second. Even if you check your latte textbook, they solve a particular question there in which the magnitude also has the same unit as the what? As a vector. So the unit of the magnitude will also be what? Meter per second. Now, guys, the next thing you are now going to do is that, the question is asking you to calculate the unit vector, right? So you just remember this formula. So therefore, your unit vector is now going to be the vector given. What is the vector given? This is the vector given. 4i plus 3j plus 0.1k meter per second. Over what is the magnitude of this vector? The magnitude of this vector is what? 5.00. That is 5. The unit is what? Meter per second. This cancel this. That cancel that. So it's going to remain 4i plus 3j plus 0.1k over 5. Now I can now rewrite this expression as 4i over 5 plus 3j over 5 plus 0.1k over 5. You can split this denominator in this form like this. So you are going to say that 4 divided by 5 is going to give you 0.8. That is 0.8i plus 3 divided by 5. That's going to give you 0.6. 0.6j plus 0.1 divided by 5 is going to give you 0.02k. So this simply means the right answer is going to be this one. There is no unit here. The one that has no unit is going to be the answer. That's option C. So option A is this. It has meter per second. This has no unit. This one has no unit. Why this one has meter per second? You see that option C and option D, they are the same, right? But this one has no unit, but this one has unit. So you are going to go for the one that has what? No unit. So this is the right answer. So therefore, guys, let's move on to the next question. Question number 9. Vectors moving in opposite direction. Guys, let me see who knows the answer to this question. Vectors moving in opposite direction are called what? Orthogonal, equal, parallel, or anti-parallel. If you know the answer, drop the answer in the comment section. Let me see those that are following. If you know the answer to this question number 9, that is vectors moving in opposite direction are called what? Okay, Abraham, anti-parallel. Okay, Smolin, anti-parallel. Okay, Lydia, anti-parallel. Okay, that's very good. So that's very correct. So vectors moving in opposite direction, they are called what? Anti-parallel vector. So you have to know that when vectors move in the same direction, they are parallel. The angle between them is going to be 0. But if they move in opposite direction, they are anti-parallel. And the angle between them is going to be what? 180 degree. Okay? Thank you for following, guys. Now, this is question number 9. Don't forget, we are moving on to question 25. 25 questions. Now, the next question we are moving on to now is this. Question number 10. Guys, question number 10. Guys, what do we have in this question number 10 is this. They said, in an inelastic collision system, only dash is conserved. A, velocity. B, mass. C, kinetic energy. D, momentum. Guys, follow me. You have to know something that basically, when I was teaching this particular aspect in tutorial, I talked about types of collision. We have the elastic collision. We have the inelastic collision. We can have the perfectly elastic and perfectly inelastic. But for the sake of this video, let's talk about the two types of collision that we can generally have. Elastic collision and inelastic collision. What is elastic collision? What is inelastic collision? Guys, we can have different type of collision. In some collision, after they collide, they're going to stick together. Why in some collision, after they collide, they're going to bounce off each other? For example, if you throw a ball at a wall, you will see that once the ball hits the wall, it's going to bounce back. Are you there? Why there are some example in which if you, okay, for this example, let's say let's say we have two cars, and these two cars, they actually collide together. So we can have some collision in which after they collide, they are going to stick together. Why after they collide, they are going to what? Bounce off each other. Guys, if they bounce off, that is elastic. So this simply means for elastic, they bounce off. So, but for inelastic, they stick together. Guys, for elastic collision, what do? They bounce off. Yoruba bounce off. Why for inelastic, they stick together? Yoruba simply means that are you there with me? So if they stick together after collision, that is what? Inelastic. But if they bounce off after collision, that is what? Elastic. But now, you have to understand something. No matter the type of collision you are talking about, note, momentum is always conserved. No matter the type of collision you are talking about. What is always conserved? Momentum is always conserved in all type of collision. So that is why in this particular article, they say that in an inelastic collision system, only dash is conserved. Velocity, mass, kinetic energy, momentum. So this simply means that even if you are forgotten, you have to know this and know this forever, that in all type of collision, momentum is always conserved. So this simply means that the right answer should be what? Option D. Do you get me? So the momentum is always conserved in all type of what? Collision. But in elastic collision, momentum and kinetic energy are conserved. But in inelastic collision, only momentum is conserved. Kinetic energy is not conserved. Now, guys, let's move on to question number 11. Guys, look at this question again. Let me see who started this live class with us from the beginning today. Look at this question. A 59 kg woman and a 73 kg man sit on a seawall 3.5 meter long. What is the center of mass? Guys, if you remember, you will see that from the beginning of this class, we've calculated a particular question on center of gravity. If you remember, from the beginning of this class, we've calculated a particular question on what? Center of gravity. Are you there? But this one we are having now is to calculate the what? Center of mass. Guys, you don't need to stress yourself. If you are talking about the center of gravity and center of mass, we are still dealing with almost the same thing. But for the center of gravity, we are going to be dealing with the weight. While for the center of mass, we are going to be dealing with the mass. So therefore, guys, If I want to calculate the center of mass, I will still use the same formula. Guys, follow me. Look at this. So because this one requires a more explanation, it requires some explanation yet. Remember the formula I gave you? Let me write the formula I gave you the other time. That would be m1 times x1 plus m2 times x2 all over m1 plus m2. Guys, remember this formula. I gave you this formula from the beginning of the tutorial today. If I calculate the center of gravity or the center of mass, I will be using this formula. Mass 1 times the distance of mass 1 plus mass 2 times the distance of mass 2 all over the total mass. Guys, now listen. I have my mass 1 to be this. I have my mass 2 to be this. But guys, how many distance do I have in this question? I only have one distance in the question. Okay, guys, before we move on, let's talk about something. Guys, if you're talking about seesaw, only a few people might know what we refer to as seesaw, but let me do a schematic diagram of a seesaw. Guys, if you're talking about a seesaw, we will have something like this. A pivot. Are you there? So there are going to be something like a meter rule on it like this. Guys, look at this. Even this idea of seesaw, it is like a swing. There's a swing like that in your secondary school. The swing is going to be in this format. In this format like this. Someone is going to sit down here. Someone will also sit down here. You will not be moving up, down. You will move up, down. This one goes up, come down, goes up, come down. You remember that, something like that. That is what we refer to as the word seesaw. Guys, once you remember this seesaw, let me now do something to you. They say that this seesaw is 3.5 meters long. This simply means that from here to here is 3.5 meters. Guys, look at this. Look at this. Okay. They say that a 59 kg woman, that simply means that the person that is sitting here is 59 kg. Guys, listen. Why the person sitting here? The man sitting here is 73 kg. Can you see that? 59 kg is sitting here. Nationwide blogger invite you to co-host. Okay, 59 kg is sitting here. 73 kg is sitting here. Now, guys, look at me. Let me ask you a question again. Guys, what is the length of this seesaw? 3.5, right? Yes. Now, guys, listen. Now, this simply means that this is the beginning of the saw. This is the beginning. And this is the end. In Yatumas, as we move from here, from this beginning point, where this 59 kg woman is sitting, the distance is 0 meters. But if I now keep counting, measuring the length, so at the end here, the distance is now what? 3.5 meters. So therefore, guys, that is why the distance from here to here is what? 3.5 meters. So this simply means that the 59 kg woman is actually at the 0.0 meter, while the 73 kg man is at the what? 3.5 meter. So therefore, this simply means that if I want to use this formula now, it will just be center of mass is equals to your M1, that is 59 kg. The distance of this M1 is what? 0. Plus your M2, that is 73 kg. And the distance is what? 3.5 times 3.5. All over 59 plus 73. All over the total mass. That is the only mistake that many people is going to make here. Are you there? So therefore, if you bring that to calculator now, you open a bracket, you press the fraction button. That would be, 59 times 0 is 0. So that would be 73 times 3.5 all over 59 plus 73. Close the bracket. This gives us, the answer is what? 1.935. That is approximately 1.94. 1.94. So the answer is what? Option A. So for this particular question, you can see how simple it is. But if you don't understand, how the question, what the question is asking you to do, you might not get it. So that is that. Now let's move on to the next question, guys. Question number 12. Don't forget, we are moving on to question number 5. I'm moving on to 25 questions for today. Question number 12. Friction force between two surfaces is this. Guys, remember that we've done friction in class. And in class, I talked about the law of solid friction. Even, I forgot to tell you something. You see that law of solid friction was actually discovered by some scientists. I think, Da Vinci, I've forgotten the name himself. I think Da Vinci and one man like that. So, now, if you're talking about the law of solid friction, guys, you don't need to cram it. It requires some things. What are the things that we usually talk about? The law of solid friction. Let me list them for you. Guys, the first thing is that force. The next thing, we talk about the nature. The next thing, we talk about the area. The next thing, we talk about the velocity. Velocity. The next thing, we talk about the normal reaction. Normal reaction. Guys, these are the first thing you have to note. If you know that you want to know the laws of solid friction, the 5 laws of solid friction, and you don't want to cram it, the first thing you have to note is that you have to know this tip. This tip simply means that, okay, whenever I'm talking about the laws of solid friction, I am going to be considering 5 words, 5 most important words. The first one is force. Sometimes, I think in class, I used motion. Okay, you can call it force or motion. The second one is nature. The third one is area. The next one is velocity. The next one is what? Normal reaction. Okay, once you've known this, then the next thing you now know is that, okay, how does friction relate to force? How does friction relate to nature? How does friction relate to area? How does friction relate to velocity? How does friction relate to normal reaction? Guys, friction is a force. But what type of force? It is a contact force. But what type of contact force? It is an what? Opposing force. So this simply means that if I'm talking about it as a force, it is an opposing force. Opposing force. Okay, guys, what do I mean by friction being an opposing force? Is that it opposes motion. Are you there? When you are trying to move forward and something is pulling you back, you are trying to move forward, but a force is pulling you backward. That force that is trying to pull you back can be referred to as what? Frictional force. So that is why friction is an what? Opposing force. That's the first thing you have to note. The next thing is that nature. If you're talking about the nature, what are we talking? What type of nature are we talking about? We are talking about the nature of the surface. Guys, if I'm talking about the nature of the surface, it will either be whether the surface is rough or the surface is what? Smooth. So this simply means that for nature, it depends on the nature. It depends on the nature. So therefore, how does friction depend on the nature? You know that there's going to be higher friction in a rough surface, and there's going to be low friction in a smooth surface. So therefore, friction depends on the what? Nature. Do you get that? Friction depends on the nature of the surface. So the next one is the area. It is independent. Independent. Guys, if you're talking about the area, we all know what area means. Being Kabashi Fesi, that's the area. Madam, once you understand the Yoruba, you don't have any problem. So area is just talking about how wide something is. Bobashi Fesi. Do you get that? So area does not affect friction in any manner. Area, how wide the surface is, does not affect what? Friction in any manner. So that is why the friction is independent on the what? Area. The next one is the velocity. Velocity. Also, velocity is just talking about the speed. And friction is also independent on the speed. It is independent. It does not depend. Friction does not depend on the velocity of the surfaces in contact. It does not depend. No matter, even if the surface is fast or it is slow, the friction does not depend. Friction only depends on the what? Nature of the surface. Whether the surface is rough or the surface is what? Smooth. Do you get that? The next thing is this. Friction is proportional to the normal reaction. Proportional. So that is that. So you have to note this. So once you've known this, then you are going to be able to solve this question. But while solving this question also, you also require some understanding. Now let's do this together. Friction force between two surfaces. The first one is that it's not proportional to normal reaction. Is that correct? No. Option A is wrong because friction is proportional to normal reaction. Friction, Fr, is directly proportional to normal reaction. Do you get that? Then we can say that Fr is equals to what? Mu R. Guys, follow me. There are some interesting questions that we are going to be doing today. Make sure that you are following. Okay? Now, the next thing. So this simply means that option A is wrong. Option B is dependent on the nature of the surface's contact. Is that correct? Yes. Friction depends on the nature. So this simply means that the right answer should be what? Option B. Don't show yourself. The next one is dependent on the rough surface. Is dependent on the area. This one is area. Is it dependent on the area? No. Friction is independent on the area. But guys, you see, another problem we always have in physics question is level of understanding and how to reason according to what the examiner is asking you to do. You know that if you are talking about the nature of surface, it can either be rough or smooth. So this simply means that friction depends on the nature of surface. It depends whether it is rough or what or smooth. So you will now see that this option B is dependent on the nature, which totally stands for either rough or smooth. But this option C is only what? Rough. So the correct answer for this particular question is going to be what? Option B. Guys, we are moving. Question number 13. Now, guys, this question number 13 is very simple. But when majority of students sees this in exam, they will get confused. And how do they get confused is that they are going to be like, can you move a shibai? Guys, if you remember very well, I think I also did a video like that on YouTube where we talk about the dimension analysis. Guys, we can use dimension analysis to do two things. If you remember, firstly, we can use it to test for the validity of an equation. Secondly, we can use it to what? To derive an equation. Guys, whenever so whenever we are talking about the dimension analysis to test the validity of an equation, guys, the dimension on the left hand side must equal to the dimension on the what? Right hand side. Guys, follow me and do this. F is equals to this. Guys, look at this. The expression given to us is that F is equals to AT plus BT squared. Guys, remember something. This F is a force. This T is a time. I am expected to look for the dimension of A and B. I'm going to share the link to the... Actually, I think the link to my YouTube channel was pinned to my bio. But that YouTube line that is there, they have blocked it. So I'm going to update that. So don't worry, I'm going to share the link to the YouTube very soon. Now listen. The question is that I should look for A and B, the dimension of A and B. Guys, firstly, listen to me. This F is force. We all know what force is. This T is time. Now, the first understanding you have to notice that the dimension for force F is equal to MLT minus 2. Listen attentively. The dimension for this F is what? MLT minus 2. This is the dimension for what? For force. Now, what the question now asks me to do is that I should look for the dimension for A and also the dimension for B. Now, you have to understand that the dimension for A, if truly this expression is going to be correct, if truly this expression that is here is going to be correct, dimensions on left hand side must equal dimensions on right hand side. If truly this expression that you can see here is correct, all the dimension on this left hand side must be the same as all the dimension on this right hand side. Guys, listen attentively. If truly this expression that is here is correct, is valid, the total dimension on this left hand side must be the same as the total dimension on the right hand side. So guys, please remember that the dimension on the left hand side here, this is force. The dimension for force F is what? Is this. You have to know this offhand. This simply means that the dimension on this left hand side is what? Is ml t raised power what? Minus 2. So therefore, guys, this simply means that for this expression to be correct, the dimension on the left hand side must also be the same as the dimension on the what? Right hand side. So this simply means that for this value of A and the value of B to be correct, there must be any of the values here in which, if I should choose this value for A, if I should multiply this A by the dimension for this capital for this T, I must get this. So therefore, guys, let's do something. You will now see that option A is ml raised to power minus 3. Option B is mlt raised to power minus 4. Option C is mlt raised to power minus 3. So therefore, guys, you see, if I represent my A as this, as mlt minus 3, and B as mlt minus 4. If I should represent A, this A as this, and this B as this simply means that my expression here is going to change to mlt minus 2 equals A is this already, mlt minus 3 times this T is time. Dimension for time is capital T plus B is mlt minus 4 times this T is also, the dimension for T is capital T times T squared. So therefore, guys, it returns to mlt minus 2 is equals to, guys, this T that you see here is raised to power 1. So this T raised to power minus 3 times T raised to power 1 is going to give me mlt minus 2 plus, this is T raised to power minus 4. This T raised to power 2. T raised to power minus 4 multiplied by T raised to power 2 is going to give me mlt minus 2. You will now see that if I should represent my A as this and my B as this, I'm going to get the dimension which is going to be the same as that in the what? Left hand side. So therefore, guys, the correct answer is what? Option C. The correct answer is option C. Note that very well. So therefore, guys, let's move on to question number 14. Question number 14. Now, for this question number 14, what do I have here? What I have here is that the gravitational force is directly proportional to dash. This question is very simple, guys. Please just remember something. F is equals to G m1 m2 all over what? R squared. F is equals to gm1 m2 over r squared. Guys, what does this mean? This means something. You see this gravitational force. This gravitational force is this. This is your gravitational force. This F is your gravitational force. But this G is a constant. Then they say that the gravitational force is directly proportional. If it is directly proportional, you have to know that there is a relationship between this force and the mass. The type of relationship between force and mass in this formula is direct. That simply means that F is directly proportional to m1 and what? m2. But the type of relationship between this force and the radius is inverse. That simply means F is inversely proportional to r squared. Do you get that? So therefore, this simply means that the gravitational force is directly proportional to dash. Right there, it is directly proportional to look at this, to square of the distance. Everybody, is gravitational force directly proportional to the square of the distance? No, it is inversely proportional to the square of the distance. So option A is wrong. Directly proportional to the square of the masses? No, it is not directly proportional to the square of the masses. It is wrong. Product of the masses? Yes, it is directly proportional to the product of the masses. This is the product of the masses, directly proportional. So the right answer is what? Option C. So don't make mistake, please. The right answer is what? Option C. It is directly proportional to the product of the masses, not square of the masses. This is what? Product of the what? Masses. So option B is wrong. The correct answer is what? Option C. Now we are moving on to question number 15. Okay? Question number 15, guys. Oh, God, help us. Question number 15. The dimension for tensile stress. Guys, remember that when we were doing this dimension class, we said that speed and velocity. Wait, let's start from the beginning. Distance and displacement, they have the same unit and dimension. Speed and velocity, they have the same unit and dimension. Work and energy, they have the same unit and dimension. Impulse and momentum, they have the same unit and dimension. Also, stress, pressure, Young modulus, shear modulus, bulk modulus, and energy density, they all have the same unit and what? Dimension. So in this particular question, we are to what? Calculate the dimension for the what? Tensile stress. Now, guys, how do we calculate the dimension for the tensile stress? It's very simple, guys. You see, whether you hear tensile stress or you hear tangential stress, please don't stress yourself. Stress in jail. Don't stress yourself. Stress in jail. That's what. So the formula for tensile stress, whether it is tensile stress or tangential stress or normal stress, the formula is still stress is equals to force over area. Stress equals to what? Force over area. Do you get that? So the dimension for force is actually mLT minus 2 and area is what? L squared. mLT minus 2, area is what? L squared. So therefore, 1 L, we cancel 1 L here, is going to remain mt minus 2 over L. If this L that is below here, total loss okay, is going to turn to mL minus 1 T minus 2. The right answer is option C. So option C is the correct answer for the dimension for what? Stress. Okay. They said assuming the Earth's mass round the sun. Sorry, this one should be moves. Assuming the Earth moves round the sun in a circular orbit. Assuming the Earth moves around the sun in a circular orbit. Radius is this. Guys, look at this. I was given the radius r to be equals to 1.49 times 10 raised to power 10 meter. That's the radius. And the period. Now, let me tell you something. We have something we called, or that's a circular motion, a rotational motion that we did in class also. We have what we called period and frequency. If you remember, Frequency is the number of oscillation completed, while period is the time taken to complete an oscillation. The unit for frequency is hertz, while the unit for period is what? Second. This simply means that period and time, they have the same unit. Even in basic manner, period and time, they mean the same thing. The time taken to complete is the period. That simply means that period is still what? Time. So therefore, this that I have here, they said period of 365. This simply, my capital T is the period. That's the time to complete. That's equal to 365.25 days. Guys, if you remember, because I know that some of you, you are not in Earth. You are not on Earth. Hello, me, Pluto Loa. If you study very well, you are going to see that today is the 366th day of the year 2024. I bet it, and then 366 days of year 2024. It's because some people don't know that today is the 366 day like that. So what are we trying to say here is that in a year, we have 366 days in a year. Do you get that? So this simply means that this period of 365.25 days is actually talking about a what? A year. Are you there? So that's that. There's no problem with that. But now, guys, they say find the speed of the earth. Guys, I'm looking for V. That's the speed. But now we have a little problem. All about the kind of problem, any problem, amen, amen. But we are looking for speed, V. We were given only radius and period. Kini mo fẹ́ ṣe? But when I say don't panic. Do you remember that when we were doing this particular aspect in class, I gave you some formula. One of these formula is that V is equals to omega R. To guarantee tí o bá ti fi jẹ Christmas chicken, because tell me bó ṣe lọ lé báyìí gbogbo yẹn ó ti fi gbogbo physics ó ti fi jẹun. Some people doesn't even remember that they are still in school. I know it's shaming, but no panic. You see, once you are doing what you are doing like this, you are going to meet up with everything you're supposed to meet up with. Okay? So you see, we have this formula V is equals to omega R. But guys, remember that omega is equals to what? 2 pi f. Omega is equals to what? 2 pi f. But guys, you also have to remember something. If I say omega is equals to 2 pi f, I know that pi is a constant, but f is frequency. In this parameter I have here, I don't have f. I don't have what? F. What do I have? I have period. You are going to remember that your period, capital T, is equals to what? 1 over f. So this simply means that my omega can change to 2 pi over... Okay? Wait. Your period T, this T is equals to 1 over f. And also at the same time, f is equals to what? 1 over T. So this simply means that this omega that is here is equals to what? 2 pi over T. The understanding you have to have here is that frequency and period, they have inverse relationship. This is period, this is frequency. So your period T can equals to 1 over f, while your frequency f can also equals to what? 1 over T. So this simply means that if you are given T, you can turn it to period. And if you're given period, you can also turn it to what? To T. So you just remember that W is equals to 2 pi f. But if f is equals to 1 over T, then W, this omega, can equals what? 2 pi over T. You don't remember that your T. You don't remember that your... Okay. V can then equals to 2 pi all over T. V can equals to 2 pi all over T. So therefore, guys, this is the formula for your V. V is equals to 2 pi over your V. V is equals to 2 pi over. Okay, yes, I'm coming. You know that V is equals to omega R, right? So V, since we have turned our omega to 2 pi over T, so V will now equals to 2 pi over T times R. Do you get that? So don't forget, we have these parameters. We have to use this formula. V is equals to omega r. The formula for omega is what? 2 pi f. But in this question, we don't have f, but we have t. You're going to remember that your t is equals to 1 over f, while f is also equals to what? 1 over t. So this omega formula that we have here, it can turn to omega is equals to 2 pi over t. You know f is equals to 1 over t, omega became 2 pi over t. So therefore, you now remember that your v is equals to omega r. Since our omega is now 2 pi over t, it now turns to 2 pi over t times r, the r that is here. So therefore, guys, let's do this together. V is now going to equals to 2 pi times my r, that's the radius, 1.49 times 10 raised to power 10 all over t. Guys, this is where we now have to listen attentively. My t that I have here is time. That is 365.25 days. But guys, the unit I have here is in second. The unit of time and period is second. But here, what do we have? Days. So therefore, guys, this simply means that we have to convert days to what? Second. You remember in your kindergarten, you usually do something. 60 seconds make 1 minute. 24 hours make 1 day. Are you there? 24 hours make 1 day. Some people do not remember that we have 24 hours in a day. So, guys, if I want to convert 365.25 days to second, I will firstly convert days to hour. You know what I have here is 365.25 days. I'm going to convert this day to hour. It's going to turn to 365.25 times 24 hours. Are you there? So to convert these days to second, just multiply by what? Oh, sorry. To convert days to hours, just multiply by what? 24. So therefore, don't forget that if you now want to convert hours to second, you will just multiply by what? 3,600 times 3,600. So I have successfully converted days to what? Hours. Firstly, multiply by 24 to convert to... Sorry, I've successfully converted days to second. I firstly converted to hour by multiplying by 24. Then convert hour to second by multiplying by what? 3,600. So you have this expression here. So this will just equals to, guys, look at your calculator. Let's do your calculator. Just press the fraction button. Once you press the fraction button, press 2. The 2 here and pi. So this is the pi of your calculator. Show the pi of your calculator. This is pi of your calculator. Show TD. And you know what I did here is that I converted days to second. So if I want to convert days, to do is that we firstly convert the days to hours. So in order to convert these days to hours, we multiply by what? 24. Are you there? So I will now convert this hour to second. So if I want to convert hours to second, I'm going to multiply by 3,600. So that is where I got 3,600. It's just a conversion of what? Days to second. So if I want to convert days to second, I will first convert to hour. And then I will convert to what? Second. So therefore, I will press the fraction button. Once I press the fraction button, I press 2. After pressing 2, I'm going to bring out this pi. Are you there? So this is the pi of your calculator. How are you going to press it? You just press shift times this radius 1.49 times 10 raised to power 10. That will just be 1.49 times 10 raised to power 10. You then control this cursor, control it down. Once you control times 24 times 3,600. So once you press this correctly on your calculator like this, then okay, I'm coming now. Okay, then price is equals to, guys. So if you check your calculator screen, you're going to see that the answer we got here is what? 2966.6. And approximate is going to us what? 2967. So that is how we got our answer to be what? 2967 meters per second. So guys, let's quickly move on to the next question we have here. Question number 17. So that because we are in December time, sorry, you are doing well. Okay, so moving on to the next one. Question number 17. Guys, in this question number 17, the question we have here is that lubricant is used to dash. Guys, if you remember, that when we were doing the physics friction class, do something, and that was friction. And I gave you an assignment. The assignment I gave you is that you should look for what we use in reducing friction. What we use in reducing friction? Reduce friction. So the answer is what? Reduce. Guys, it is not to stop. It is not stopping friction. It is what? But this is it. Your acceleration A is equals to what? V square over R. But get about the question. V1 okay. You also remember that your V is equals to omega R. You will not remember that your A is not going to equal. So see, okay, V is equals to omega R. What they can omega R all squared over R. What did something like omega square R square over R, guys? So now, guys, you know that A is not equals to omega square over R square. This simply means that one R is going to cancel one R. Omega square R. So this simply means that the formula for your A is equals to what? Omega square R. You can see that. Okay. The next thing I'm not going to do now is this, guys. Look at me. In this question, I don't have omega again, right? I don't say that in this question I don't have frequency, but I have a year. Abi? So that will not equals to 2 pi. 60 minutes make 1 hour. 3,600 seconds also make 1 hour. 1 week. 4 weeks make 1 month. But okay, everybody, how many months makes a year? 12 months make a year. Now the question is that how many days? How many days make a what? Make a year. So we have a year here. Oh my God, this is the period. Abi, okay. So formula A can turns to 2 pi over T all square times R. Do you get that? So this is the formula we are to use. Relation we want to get. If you now look, yes, 366 days makes a leap year, yes, actually. So this acceleration here that we want to do, it is 2 pi over T all squared, Abi, times R. Abi, we have pi is a constant, we have R is a radius, but this T is a what? Is a period. Is a period. And this period is talking about this year. So 365 days, okay, let me say 1 year is equals to 365 days. 1 year is equal to 365 days. So this 365 days, I'm going to convert it to second. 1 year is equals to what? 365 days. I will then multiplying it with what? 24. This will be 365 times 24. I will then convert these hours to second by multiplying it with what? 3,600. Do you get that? So that's it. So I'm going to convert these days to hour by multiplying with 24. The acceleration A will just equals to, open bracket, 2 pi over the period. This T is the period, and it's talking about this particular value here. That is 365 times 24 times 3. The radius R, 1.496 times 10 raised to power 11. That's it. So guys, bring out your calculator. So you are going to press, you are going to open brackets. You will press the fraction button. You will press 2. You will press the pi. That is shift this. Shift this. Shift this. Okay? You will control the cursor down. You will then press 365 multiply by 24 times 3,600. You will close the bracket. You will then put square. We multiply again 1.49. If you press it correctly like this on my calculator, you can see either the answer is going to be 5.94 times 10 raised to power minus 3 meter per second. Convert 75 miles per hour to meter per second. Convert 75 miles per hour to meter per second. Now, how can we convert 75 miles per hour? Okay, number 19, they said convert 75 miles per hour to meter per second. Guys, the first problem is that, Madam, you just have to know that 1 mile It's as if you are doing 75 miles per hour. So we are going to convert this 75 miles per hour to kilometer per hour. So the Ali convert in mile. And how do we do that? By multiplying with 1.609. That will then be 75 times 1.609. So if we press 75 times 1.609, then we are going to get 120.68. 120.68 kilometer per hour. So I will firstly convert this mile per hour. To convert kilometer per hour to meter per second, multiplying. So if I want to convert kilometer per hour to meter per second, I'm going to multiply by what? 1,000 over 3,000. So I'm going to do 120.68 times 1,000 over 3,600. Then you are going to get 33.52 meter per second. So the right answer is what? Option C. Okay, that's very. In which of the following how many? Okay, if you're talking about mechanical energy, guys, mechanical energy is classified into how many? Let's say mechanical energy, the two mechanical energy. Thank you very much. Kinetic and what? Potential. Now, guys, kinetic energy is the energy possessed by virtue of, okay, let me say energy in motion is kinetic. Energy at rest is potential. Do you get that? When something is not moving, it possesses an energy. That energy is potential. But when something is moving, it also possesses an energy. That energy is what? Kinetic. Now, guys, let's look at this very well. Guys, this particular question is very simple. But thinking about Frabalin, you might have any little problem. Let's look at this. Kinetic or potential, firstly. Guys, the person is what? Is at rest. So energy possessed at... So a man standing with heavy load. That man standing with heavy load is what? Potential energy. So option A is potential. Option B, an acrobat supporting two men on his shoulder. Supporting two men on his shoulder. But option C, a girl chewing a piece of chewing gum. Now let me tell you something. This is the girl chewing a piece of chewing gum. You will say that what we are dealing with now is the chewing of the chewing gum. On chewing gum, as it is chewing the chewing gum, is that potential or kind of gum? It is undergoing motion. So that is what mechanical particular question. Option A is potential. Option B is potential. While option C is kinetic. Option D is none. What do you think the right answer to this question will be? It's going to be option C. This is a question that is trying to test your level of intelligence. Question 21. Please, everybody, look at this question 21 very well. This question 21. Please, I want to do something. Everybody, especially if you were not in class, when we did friction. Please listen attentively, guys. This I want to explain is very important. It's very important. This particular question is very simple, but you have to understand something first. Everybody, if we are talking about friction, listen. If you're talking about friction, we have different cases. I think in class we only did like 4 cases, but the first case is that I have a surface like this. Everybody follow me. I have a surface. Don't forget that friction depends on the nature of the surface, either rough or smooth. When it is rough, there is more friction. So this surface is rough. I do like this. This is rough. Guys, follow. The next thing now is this. If I place an object on this surface, the weight of the object always acts vertically downward. Everybody follow. Whenever I place an object on the surface, the weight of the object always acts what? Vertically downward. Now, you see, before I start talking about this, whenever an object is placed on a surface, we always have four forces that will be acting on the object. The forces that will be acting on this object, they include, the first one is the weight. The second one is the normal reaction. The third one is the forward force. The fourth one is the frictional force. Everybody, look, show the question 21. You have to understand this particularly. Once I'm talking about friction, I have a case. The case is that I have an horizontal surface. I will place an object on this horizontal surface. Whenever I place an object on an horizontal surface, four forces are going to be acting on this surface. The first one is the what? Weight. Guys, the weight always acts vertically downward. That is why I wrote like this. The second one is the normal reaction. This normal reaction is always represented as R, sometimes one little N, either anyone you want to use. I'm going to use R. You see this normal reaction R is always acting perpendicularly to the surface. Normal reaction R always acts what? Perpendicularly to the surface. Guys, perpendicular. We have four different forms of perpendicular. The first one is this. The second one is this. The third one is this. The fourth one is this. So normal reaction always acts perpendicularly to the surface. So this is the surface, this is the block, the mass, right? So the normal reaction is going to be acting like this. Are you there? So you are going to indicate the weight acting vertically downward. You will indicate the normal reaction is going to be acting vertically upward, but perpendicularly to the surface. Do you get that? The next thing is that there will be a forward force like this. This one is going to be trying to pull the object forward. Since the surface is rough, there's going to be a frictional force is going to be acting backward. You must understand this. You must be able to sketch this anywhere, anytime. So from what I have here, I can then say that this R is equal, upward is equals to downward. R is equals to W. Then remember that W is equals to what? Mg. And this F must equals to FR if it is at rest. Are you there? So therefore, F is equals to what? FR. But you're going to remember that the formula for my FR is equals to what? Mu R. So this FR can also equals to what? Mu R. Are you there with me? R is equals to W. R equals W. W is equals to Mg. This forward is equals to backward. F is equals to FR. And FR is equals to what? Mu R. You will now remember that your R was equals to W and is equals to Mg. So this can also equals to what? Mu Mg. Do you get that? So this is just a general sketch. You have to know this offhand. Now, guys, question you. What do you have here? A block of mass M is held in equilibrium against a vertical wall. Ogiri landu pẹ̀lú maybe you. Vertical wall. This one we sketch here is for horizontal surface. But the one we have here is what? Vertical wall. Different operation la machine, baby. Guys, this is a vertical wall. Guys, look at this. This is a vertical wall. Okay. We've seen the vertical wall. Now, guys, they said a block of mass is held in equilibrium against a vertical wall. So therefore, we are going to indicate the block. This is the block. Guys, this is the block. This is the wall. This is the block. Guys, let me now ask you a question. Once we've written the block to this wall, you have to firstly indicate something. Guys, what is that? The weight. The weight of an object always acts what? Vertically downward. ASAP, show the weight. It is going to be acting vertically downward. Guys, you will now remember that after the weight, the next thing is the normal reaction. Now, this is where the understanding is very important. The normal reaction is going to act perpendicularly to the surface. The normal reaction is going to act what? Perpendicularly to the surface. So there is the surface. The normal reaction is going to act perpendicularly to this surface. Perpendicularly to the surface. So this is how you are going to represent your what? Normal reaction R. This is how you are going to represent your what? Normal reaction R. The next you are now going to indicate is that you are going to indicate the force. This is the force that is acting on this object. Then you will indicate your frictional force Fr to go up. The reason I'm going to be indicating my frictional force Fr to go up is because this mass, according to what is here, is going to be coming down. The frictional force is going to be what? Going up. Then from here, I'm going to say that, look at this, I'm going to say that my Fr upward is equals to downward is equals to W. So therefore, my Fr is equals to what? Mg. Abi? So another thing that I'm going to say now is that my F, this force F, is equals to what? Is equals to R. Force F is equals to R. Now, at this point, we are going to remember something. What we are going to remember now is that from what we have here, our Fr is equals to what? Mu R. Our Fr is equals to what? Mu R. So if our Fr is equals to mu R, then we can say something from this expression that we have here. Are you there? This Fr is equals to mu R. So mu R is equals to what? Mg. Then you are going to remember that your R is equals to what? F. So therefore your mu F is equals to what? Mg. Then F is equals to what? Mg over mu. So the final answer here is they said the maximum value of the horizontal force is what? Dash. So the answer is what? Mg over mu. So you can see this question is very simple, but take note very well. Now the next thing is this. We have to end this live in the next 10 minutes. We will soon be done, actually. We will soon be done, guys. So the next question is number 22. Arrange in descending order. Now, guys, if you are arranging in descending order, that simply means we are moving from the highest to the lowest. Now, let me just tell you this. Let me tell you this so that I will not waste much time. You see, the answer for the descending order here is that the static frictional force will be greater than the sliding. Why the sliding is greater than the rolling? The static frictional force is greater than sliding force. Why sliding force is greater than what? Rolling force. So the answer should be D. But let me explain a little. Surely, if you're talking about friction, we can have two. We can have the dynamic frictional force, and we can also have the what? Static frictional force. Don't forget that frictional force is a force that opposes motion. Frictional force is like a force that does not want a object to move forward. Force, object frictional force. Are you there? So therefore, this simply means that we now have two types. We have the dynamic frictional force. We have the static frictional force. Static frictional force is the frictional force when the object is not moving. While dynamic frictional force is the frictional force when the object is moving. Abi? Now, static, it is not moving. Dynamic, it is moving. Frictional force is the force. Take over the king can move. That simply means that in static frictional force, either is going to be greater than the dynamic frictional force. The reason why static frictional force is going to be greater than the dynamic frictional force is because the object is not moving in static. Why frictional force is a force that does not want the object to move? Since the object is not moving in static frictional force, that simply means that what? That static frictional force is going to be greater than the what? Dynamic frictional force. This dynamic frictional force can either be rolling or what? Sliding. So you then have to know that the sliding frictional force is also greater than the what? Rolling frictional force. So therefore, the right answer for this number 22 is what? Static greater than sliding greater than what? Rolling. Guys, the next one. Given the vector this, guys, Mfect, understand the question here, please. You have to know something. Look at this vector. They say that the first one is 2i. The first vector is 2i minus 3j minus k. And the second one is minus 6i plus 9j plus 3k. Guys, listen to something. We have what we referred to as parallel vector. Guys, let me give you this hint. If vector A is equals to k vector B, they are parallel. Guys, look at this. If vector A is equals to k vector B, see vector A, if it is equals to k vector B, they are what? Parallel. What is k? K is a scalar number. Are you there? It simply means that if a vector is gotten from another vector by the multiplication of a single number, they are going to be said to be what? Parallel. So guys, look at this. We have vector 2i minus 3j minus k and minus 6i plus 9j plus 3k. Now guys, talk to me. You will see that this vector is gotten from this vector by the multiplication of a single number. Which number is that? Minus 3. Guys, what is minus 3 times 2? Minus 6. What is minus 3 times minus 3? Plus 9. What is minus 3 times minus 1? That is plus 3. So whenever we get a vector from a particular vector by the multiplication of a scalar number, they are said to be what? Parallel vectors. So the right answer is what? Option A.